So now if we look at the next example just gives us, again, it looks like two angles and a side, just like it did before. However, this time when we go to draw in the details on the triangle, it's not going to be a right triangle, because look at the two angles that were given already. So let's look at it. Angle B this time. So let's call this angle B. That's 25 degrees. They now have a little bit steeper here because angle C happens to be 85 degrees. And so this must be angle A. Well, they also gave me knowledge of side A. The side A is across from angle A. This is where side A would be, and it's worth 6. So let's look at the things that we need to go and find values for. I don't know anything about side C. I don't know anything about side B. And I don't know anything about this angle A right here. So let me change its color. Those are the 3 things I have to go and find. Take a look at your diagram and what you just were given. You were given a side, but it's between 2 angles, because we were given this angle, 85, this angle, 25, and the side in between. So this is actually what we call an ASA, oblique triangle. There is an advantage of having SAA like we did before. That's because you're given a pair of information. You need to have a pair of information in order to get the law of sines actually started. And so when we look at this, we have 2 angles, B and C, but we have side A. So there's no pairs of information. I can, however, find angle A's value pretty quick. And if I can find out angle A and use that with side A as one of my fractions for my proportion, that'll be a whole lot easier for me. So let's figure out how big angle A is. We know that if you have angle A plus 25 degrees plus 85 degrees, that should be 180 degrees for the sum of the interior angles of a triangle. If you add 25 and 85 together, that gives you 110. Subtracting 110 will give you 70 degrees. And so here's one of our unknowns that we needed to find. Now for us to find the 2 sides. Well, the reason for going out here and finding angle A in the first place is so that you and I could come up here and say, now I have the sine of A, because A is actually 70 degrees. I also knew the side across from angle A, which was 6. So that starts off our proportion. Now it's up to you. Would you like to find side B or side C? It doesn't really matter. I'll just go ahead and find side B. To find side B, I'll have to use the 25-degree angle, which is across from side B. Now by cross multiplying and solving for B, you'll end up with 6 times sine 25 divided by the sine of 70. So if you put that on your calculator, and we'll look to see what we've got. And when you do the math, you should end up with something like 2.698, which actually ends up being 2.70 if we rounded 2 decimal places. So 2.70 is the rounded value. Again, because we may need this later on, it's great practice to start learning how to store things into your calculator. You can now go to the store key. This time we want to store this value 2.698 blah blah blah. For B, I can go back to that alpha B that I was using before. You can go back to whatever letter you'd like. I'm on a new problem, so I can just do a different store. Now he's stored in B. Now I want to find side C. Side C, I can start him off the same way that I did for side B. Use the 70-degree angle, which was across from the given value of 6. This time I'm going to use the sign of 85, and that's going to find me the value of C. Cross multiply again. C is equal to 6 times sine 85 degrees divided by the sine of 70 degrees. And if you'll do the arithmetic now for me. And let's see what happens here. We get an answer of 6.36. 6.36. Now, if you go back to your triangle, I was trying to talk to people in 8.1 about, we need to have good number sense and so forth. So in order for you to kind of know if your numbers are in the right positions or not on your graph. So we know that if we go across from angle A, which ended up being, let me put him in here, a 70-degree angle. Let's look at the angles. 25 is the smallest, 70 is the one that would be in what we would call in the middle, and then 85 is the largest. Whoever is the largest angle has to be across from the largest side. Angle C is the largest. Side C was 6.36. Angle A was 70. He was next in line. He's across from 6. And then our last angle, which is our smallest angle, 25 degrees. He's across from 2.70. These measures are not proportional. The sine of the angle to the opposite side is proportional. So all I can do is say that the smallest angle, 25, is definitely across from the smallest length. And the largest angle is definitely across from the largest length. And hopefully that's enough to kind of make sure that we have the right answers.